Hey everyone, in one of the previous videos you would have seen how we can make use of list data structure, and we saw various functions that we can use with list. In this video we are going to look at yet another data structure that Python provides, and that is dictionary. So we are going to see how we can create a dictionary, and we are going to look at various functions that we can use with it. Before we get started, let me tell you in which situations it is ideal to use a dictionary data structure. So dictionary is used when we have to store elements that have some sort of attribute attached with them. That is, we have some elements and we also have to store some sort of property along with every element. In other words, in dictionary every element has two things, that is key and value. So there will be a key value pair for every element, where this value stores the attribute of the key. Another thing to note is that dictionary is stored in memory as hash tables, which makes it faster as compared to other data structures. So if you have some million entries and on one side you store them in the form of list and on the other side you store them in the form of dictionary, accessing these elements through the dictionary will always be faster. This is because accessing elements in dictionary doesn't go in sequential manner. Okay, so let's get started. And I believe you people might be comfortable with IPython, so I'll continue using that. Now let me create an example dictionary here. Assume my aim is to store names of a few people, and along with that I also want to store the age of these people. So here I have this age, which is an attribute that is attached to every person. So here I have two things. The key is the name of the people and value is their age. So this is the sort of information that I want to store. Let me create an example dictionary here. So I'm going to add a few people's names and their age. Let me add a few elements here. Okay, so I add another element. And I add another element. Alright, so this is how we create a dictionary. So you note here that every element has two things. So this is the name, which is the key here, and this is the age, which is the value here. So this is the key value pair, and we separate them with comma and we add another element and so on, and the elements are kept inside these braces. So you can print this dictionary. An interesting thing to note here is that these values might not necessarily be integers. So rather they can be strings, they can be floats, they can be another list as well, they can be another dictionary as well. So this is sort of flexibility that dictionary provides us while its operation. Now let me tell you how we can access the elements of a dictionary. So it is important that whenever we access, we should have the key. Now let me show you a usage which doesn't work with dictionary. Let me try accessing the first element by writing this D0. Now this is not going to work. Now this is because there is the elements in dictionary are not associated with index, unlike the case of a list. For example, in list you can access the elements using their index. However, it doesn't happen in dictionary. This is because there is no association of any index with the elements. The only association that takes place in a dictionary is between the key and the value. So just in case you want to access this element Annie, you would have to access it through the key. So I'll write the key here and I'll be getting the value, that is 25. So this is how we access the elements of a dictionary. Now why is this sort of thing happening? So D0, as I showed you, is not working. This is because the order of elements in a dictionary is not important. Basically, we cannot control the order in which the elements are displayed. Let me print dictionary D. Okay, this is what I wanted to show you. We had added first Annie, and then we had added Yo-Yo, and then we had added Sid. However, when we are printing this dictionary, we are getting a different order. Now this is because it's up to the dictionary how it is storing the elements in the memory. So they are not like they're not stored in the same sequence in which we add the elements. Now let me show you how we can update the elements in a dictionary. For example, I want to change the value of one of these elements. So assume I want to change the value of this element to be this, and then I print the dictionary. So you see the value has been updated. And now let's see how we can add more elements into this dictionary. So let me add one more person here, say John, and I want its age to be this number. And now let me print this. So this element has been added into the dictionary. Now a point to be noted here is that the syntax for adding an element like this and the syntax for updating some value in the dictionary are the same. So just in case the element is not present, it will be added, and in case the element is present, its value will be updated. So it's that simple. Now let me show you how we can delete entries from a dictionary. So the keyword for that is del. Now assume I want to remove this element John out of this dictionary. So I'll access it using the key again, as I told you. So I'll write this, and this element should have been removed. Let me check. I'll print this. Okay, the element has been removed. Similarly, if you want to remove all the elements from the dictionary, you can also do that by using a simple function, that is d.clear. So what this function will do, it will remove all the elements from the dictionary, but the dictionary will stay. So you can add more elements later. I will not use it because I do want this dictionary as of now. And in case you want to remove the entire dictionary from the memory, you have another keyword. You can just write del d. D is the name of dictionary, and the dictionary will be removed. So again, I will not execute it. Now let me tell you a few functions that might be useful while we are doing the analysis of social networks. One of the functions that is quite used is to check whether an element is present in the dictionary or not. So assume I want to check whether the dictionary has an element Annie or not. So I'll write d.hasKey. So this is an important function. It's quite frequently used. So since I can't see the entire dictionary, I can just execute this function and see whether Annie is present in it or not. So it gave me true, which means the element is present. If I want to access all the keys from the dictionary, I can just write d.keys, and it will give me a list. So this is basically a list of all the key values from all the elements. Similarly, if we want to access all the values, we have this function d.values. Again, it gave me a list which is having all the ages of all the people. Now there is one more function which is again quite frequently used, and that is items. So in case we want to access key as well as value for every element, we can make use of this function d.items. So you see here again we got a list, but the element of the list are basically tuples, where every tuple has two things. First is key and second is value. Also, if we want to access these elements one by one, we can use a for loop. Let me show you that. So what I want is I want to access the individual elements out of these tuples that we're getting from this items function. So I'll write for I in d.items. So this d.items is going to return me a list of tuples, and I'm just going to print them. Let's see. So what we did, we accessed these elements one by one, that's all. Now if you want to access key separately and value separately, you can use the index of these elements. For example, here I can write I0. So I0 will point to the key here, and I1 will point to the value here. So I can write I0 has age, for example, I1. Okay, so what we are doing here is we are accessing the individual elements of the tuple by the index. So that is always possible. Now let me show you how we can quickly create a dictionary where the elements follow some sort of pattern. So I'm going to make use of for loop for creation of a dictionary. So let me create this dictionary where the elements should be of this sort, and I'll use for loop for x in range say 11. In 11. Okay, so okay, this dictionary is created. So the elements in the dictionary are of this sort, where key is x and the value is x square. So this operator you might be knowing in Python, it is exponentiation operation, and I'm using for loop where the x is going from, so this range returns a list going from 0 to 10. So 11 is excluded. Let's print this dictionary and see what it contains. So we have 0, 1, 2, 3 up to 10 as keys, and their squares are as the values. So this is how we can quickly create a dictionary. We can also play around with it. For example, I want only even numbers, so I can add another condition here. If x mod 2 is equal to 0, that's all. So let me see what the dictionary contains. It now contains only even numbers as the values, and even numbers as the keys, and the squares as the values. We can also check the function that we just learned has key. So if I write d1 dot has key, if I write 3 here, it should return false because there is no odd number as the key here. So I think that was a pretty much basic introduction to dictionaries. Plotting is an integral part of any sort of analysis. Since in this course we are going to analyze social networks, we might need to plot our results to better visualize them. Therefore, in this video, we are going to see how we can make use of a package called matplotlib, which is provided by Python for plotting purpose. So let's get started. So we might need to import this package first of all. So the package name is matplotlib. Inside matplotlib, we have pyplot, which contains all the functions for plotting. I'm going to give it a short name so that it is easier to use. Now this means we are going to use plt instead of matplotlib.pyplot now on. So that will make things easier. This package has a lot of functions for plotting and to customize our plots as well. The very basic function that this package has is called plot. So we are going to first use that function plot. So I'm going to write plt.plot. After that, I'll be giving various parameters to this plot function. Now again, this plot function has various versions. To start with, we are going to look at the basic version of this plot function, which accepts a single list as a parameter. So what I'm going to do is I'm going to pass a list having some 5 elements here. All right. So this is a very basic usage of this plot function. In order to see the plot, we need to use a function that's called show. So I'm going to write plt.show. When I do that, I get this plot in the other window. As you can see, this is a very basic plot with no customization. There is no title of the plot. There is no title on the x and y axis. And you see the x-axis is starting from 0 and the y-axis is starting from 1. So let me tell you the reason for it. We called the plot function with single parameter, which was only one list. Now when we do that, the values that we pass in the single list, they are taken as y values, which means this 1, 2, 3, 4, 5 are taken as the y values of the plot. And since we have not given any values for the x-axis, they are automatically taken up by matplotlib. Now since the index in Python starts from 0, the x values also start from 0 automatically, which means x is equal to 0 is assigned a y value of 1, x is equal to 1 is assigned a y value of 2, and so on. So you can see in this plot, x is equal to 0 has y is equal to 1, x is equal to 1 has y is equal to 2, x is equal to 2 has y value of 3, and so on. So of course we can always change that, but when we provide only one parameter to this plot function, this is how it happens. But we can always customize things. We can make this plot specific to our requirements. So we're going to see how we can do that using other functions. Now I'm going to close this window and I'm back on the command window. Now let us look at some more versions of this plot function. Let's use a plot function where we are passing both x and y values. So what we are going to do is we will be passing two lists as parameter. The first list will be the values for the x-axis and the second list will be the values for the y-axis. So I'm going to pass say 1, 2, 3, 4 and 5 as x values, and for y values let me just pass their squares, for example. So this is what I'm passing here. So I'm explicitly passing both x and y values. All right. Now to see the plot, I'll write plt.show and I see this plot. So here the values, the corresponding to 1, we have 1, corresponding to 2, we have 4, and so on, right? Okay, now I'm closing this window. I'm going to show you some more versions of plot function. Let's get back here. So by default, we were getting a blue line here as the plot. We can always change it. We can change the color. We can change the appearance of the plot. For example, by default, we were getting a line. We can always change it to some points. Let me give you an example here. So I want the plot to be red in color, and say I want the dots, the points, and not the lines. So I'll write RO here. Let's see what we get. So every time you call this plot function, you have to write plt.show as well in order to see the plot. Now here you see, instead of the line, I'm now getting the points, and that too red in color. Okay, and in case you want the line as well, so you can put a dash here, enter, and then plt.show. Now you get the points as well as line, right? So these are some of the versions. You can even change the other things. Let me show you some more markers here so that you can play around with them. For example, if you want blue triangles, I'll just write this symbol here, and then I'll write plt.show. Now you see you're getting the triangles here. Okay, and if you want triangles as well as lines, you can do that. So you're getting both the things. And if you want the squares, so here you can write S and say I want yellow squares, and then I'll write plt.show. So we're getting squares here, and the line is also there. So you can basically look at the documentation, and you will see there are various markers, and you can just play around with them and use them as per your requirement. As you saw that there was no title for the plot, there was no title on the x and y axis. So let us try doing that. The function that we'll be using for doing that, there is title function. So we'll write plt.title, and we can give the title of the plot here. Let me give something like squares of the numbers. Okay, and I also want to give a title for the x-axis. The function that we'll use for that is xlabel. So I'll write plt.xlabel, say the values. I also want to give a label for the y-axis, so I'll write plt.ylabel and maybe the squares. Now again I'll call this plt.plot. Okay, and then I'll call plt.show. Now you see we've got this the title of the plot. We have the title of the x and y axis as well. Okay, let me also show you that you can also change the color and the font size of these labels as well as per your requirement. So let me give you one example here. I want to change the x label to be, say, red in color. So we already made use of this function, right? X label, plt.x label, sorry. So we had only passed the label here. Okay, so I'm going to pass a few more parameters here to customize it. So I'm going to change the font size, say 18, and I also want to change the color. So I'll write color is equal to, say, red. Okay, now label is changed, so I'll call the plot command again, and then I'll show it. So you see the X label has changed, the color has changed, the font has changed. So you can always keep it the way you want it. Another thing that I want you to notice here is that the values on x-axis are starting from 1 to 5, and the values on the y-axis are starting from 0 to 25. And if you see, the values that we had passed are, the x-axis values are from 1 to 5 and y values are from 1 to 25. So it has automatically chosen the values where to start from and where to end, but we can always change it, we can always customize it. So let me show you how we can do that. The function that we use to change the starting and ending of the axis is called plt.axis itself. So I'll write plt.axis. Now this function accepts one parameter, which is a list having 4 values. So the first value is the starting of x-axis, the second value is the ending of x-axis, the third value is the starting of y-axis, and the fourth value is the ending of y-axis. So here you see our values, x values are starting from 1 to 5. So let me, in order to show you its usage, I'm going to give it 0, the starting of x-axis, and the ending of x-axis I'm just like that going to give 6, just to show you how it works. And now I have to give the starting of y-axis, I'm going to give 0 here, and the ending of y-axis, you see it's up to 25. So let me just give it 30 so that we see how it works. Alright, so again I'll call plt.plot and then I'll call plt.show. Now you see here x values are now starting from 0 to 6 and y values are now starting from 0 to are now going from 0 to 30. Alright, so you can, this is always in control, you can change it the way you want it. Let me now show you a couple of more features of this plot function. For example, you got a very thin line as the plot. If you want to increase the thickness of this line, you can do that. Let me show you how to do that. So plt.plot, let me reuse the same function. So here we were passing some 3 parameters. I'm going to add one more parameter here for the thickness of the line. So the keyword is line width here. So line width is equal to say 3.0, by default it is 1.0. So I gave this line width and then I'll call plt.show. Now you see the thickness of this line has increased. So you can always change that. It's all about decorating your plot so that it is better visualizing. Okay. Another thing that is sometimes needed is a grid that you want to display in your plot sometimes. So by default it is turned off, but you can always turn it on by passing a true parameter there. So the function that we use there is grid. So I'll write plt.grid and I'll pass true here, which is by default false. So once I do that and I call this plot function and then I'll call the show function, you see there is a grid here. Right, so that's there in the background. You can always turn on and off as per your requirement. Okay, you can also save this plot if you want. There are various functions, there are various features here that you can make use of. Okay, let's get back here. Okay, as of now we were showing only one plot inside the plotting region, but that's not necessary. We can always display multiple plots inside the same plotting region. Let me show you an example for that. Let me create the x values by using a loop, for example. That will also show you how you can use a loop to create a list if you don't know already. So I'll write I for I in range 21. If I write this, I'll get the values from 0 to 20, excluding 21. So basically I'll be getting 21 values. Let me keep 20 here. Okay, so I got the x values and then I want to plot this x along with its squares. So I write x and this is exponential operator, and I want it red in colors, maybe in line. Now in case I want to also display the x cube as well in the same plotting region, I can do that. So let me show you how to do that. So I'll write x cube here and say I want that blue in color, blue lines, and assume I want to display x to the 4 as well in the same plotting region. So I'll write x to the 4 here and say I want that yellow in color. Okay, I do this, but there is an important point to be noted here which I want you to know. When I run this command, it should show me an error. Let me see. Yeah, it's showing an error. Now what is the reason for that? The reason is that x is a list, right? This is a list, and then we are applying this exponentiation operator on a list, which is not allowed in Python. So what we can do here is that we can make use of a package which is called numpy, which allows such sort of operation. So if we convert this list x into a numpy array, then in that case such operations are allowed. So the crux is that this kind of operation is not allowed on lists, but it is allowed on NumPy arrays. So let us do one thing. We will make use of this NumPy package. Let me import that. Now I'll basically convert this x into a NumPy array. So I'll write numpy dot array. This is the function. So I'm passing x as a list and I'm getting it as a NumPy array. Now after that, if I call this plot, it is not giving me an error, and it's working fine. Now we can do plt dot show. So here you see I'm getting all the three plots here, yellow, blue and red. I'm getting all the plots here. Now since this, due to these dimensions of this y-axis, you're not clearly able to see this red line, but you can always do that. As I told you, you can customize, you can change the starting and ending of y-axis, so you can play around with that. All right, okay, as of now we have seen only a simple plot function, right? We have seen a simple plot in form of lines or points, but let me tell you that we can also have different kinds of plots using this matplotlib package. For example, we can have scatter plot, we can have bar plot, we can have heat maps as well. So there are various kinds of plots that we can draw. Now I'll be showing you some 2-3 examples just to give you an idea. I'll show you how to draw a scatter plot. So in order to draw the plot, let me create a list randomly. Also, that will show you how you can make use of a random function. Okay, before that I need to import the package, so I'll import random package, and then I'm going to create a list which will be having 100 random values, right? So how do we do that? I'll make use of the function randint from this package random, and I want the values to be between 1 and 100, and I want 100 such values. So I'll write for I in range 100, right? So I'll be getting 0 to 99. I'll be getting 100 values here. All right, so let me also have y values randomly. So basically I'm having 100 random values as x values and 100 random values as y values. Okay, now let me draw the scatter plot. So the function is scatter itself. So I'll write plt.scatter x comma y, and in order to see the plot we have to write plt.show. Okay, so here we get the plot. Now again, the kinds of operation that we applied in the simple plot function, like we changed the axis, we changed the color, we changed the titles and everything, that also we can do here. For example, here you see by default the x axis is starting from -20, right? And same goes with the y-axis, which is not looking so good. Let me change that. So what I'll do is plt.axis. I'm going to pass a list with 4 values, starting of x-axis to be 0 and ending to be 100, starting of y to be 0, ending to be 100. Now I'll call this plot function again. Scatter, plt.scatter, and then plt.show. Now you see x and y is starting from 0 now, and it's looking quite better. You can play around with it. We can change the colors of these dots. All right, let's get back here. Now let me show you another kind of plot that you can have using this package. If you want a bar chart out of your data, so you can use a function bar, plt.bar. I'm going to use the same x and y values here again. So that's all, plt.show. Okay, we get a bar chart here. So by default we always get a blue color, and yeah, so axis is fine here, 0 to 100, because we had set it already. And so you can again play around with customizing this plot as per your requirements. So these were just a few examples of the kind of flexibility that this package provides you. You can look into the documentation and look for more functions as per your data, as per your requirement. Thank you.